So I'll get going. So if we'll get done obviously before the 9:05 mark for you here. Um, if for any reason you are having issues with, you know, the connection, or it's in and out, or it's spotty, uh, or you get, kicked off, whatever, I am recording this. So once it gets done recording, I usually clean it up a little bit and get rid of all the downtime at the beginning. And then I'll post that into Schoology under a digital day assignment thing in Schoology. So like I said, if there's anything that you miss or you didn't get back in or whatever, don't worry. You'll be able to kind of see what we did, and you have to watch that on your own time. So I will be checking your notebooks on Tuesday when you come back. So then I expect to see the page done that we're going to be working on today. All right. So let's get to it. So go ahead and open up to this page here. We were working on this yesterday. And if for some reason you weren't here yesterday, you can go ahead and copy down these numbers here. We used pages 126 and 129 in the ebook in order to get this information here. So remember that what we were doing is we were comparing cities, all right, that had very similar latitudes, but the biggest difference, and the only thing that really matters, is how far are they away from the ocean. So remember, if they have a distance of 0, right, like these 3 cities do, that they are right along the coast. Other cities that are along their same latitude are considered to be inland cities, okay? So we have 3 sets of cities to look at because it's helpful to have more than one data set to make a conclusion, all right? So let's take a look at Homer first. Okay? So Homer was a little bit. Homer, Alaska here. Again, similar latitudes, okay? There's about a 1 degree difference in latitude, but it really is not going to make a difference in the long run here. Remember that I'm curious about latitude because we've talked about how latitude influences climate. And that's why in Minnesota, we're sort of more, right in the middle in terms of we're not too hot and we're not too cold. If you're closer to the equator, you're warmer. If you're farther from the equator, you're cooler. All right. So if the latitudes are the same, then we would expect similar climates, similar temperatures, similar precipitation. So let's see if that holds true. All right. So if we're looking at Homer versus Bethel, those are the 2 that we're comparing. We can see that Homer is the one that is on the coast, and Bethel is the one that is inland, about 96 kilometers, about maybe like 50, 60 miles or so inland. Okay, so 50, 60 miles, that's like a little farther than Mankato. That's how far away these cities are apart from each other. Or not from each other, but from the coastline. So annual precipitation, we can see here that Homer gets 64.6 centimeters and Bethel only gets 38.8. So that's almost a 30 centimeter difference between the 2. So I'm just going to mark with kind of like a star, and if you want to too, you can do that. Homer gets more precipitation, okay? And then when I look at the last column here, again, I'm not as concerned about average temperature, but I'll look at my last column here in terms of my temperature range. So this is from your highest average temperature to your lowest. Homer's temperature range is 17.2 degrees, while Bethel's is 27.5. So it's almost a 10 degree bigger difference in range of temperatures, meaning that it gets much cooler and much warmer throughout the year. So their temperature range is larger. So I'm going to go ahead and put a star next to this one because that one has the lower range, which is kind of what I want to compare. Okay. Now let's look at San Diego versus El Centro. So the 2 that are in white here. So 32, same latitudes essentially, no difference there. Distance to the ocean, again, 0 versus 144. It's probably about 100 miles inland. And then you have a difference in precipitation. Again, San Diego, it's 30 centimeters. El Centro only gets 7.5 centimeters, all right? A centimeter is about the length of the width of like your pinky. Now, if you have larger hands, that may not always be true. So about like 7 of your, fingers essentially on top of each other equals about 7.5 centimeters. That's not very much. That's actually a part of the country that's very dry, which a lot of California is. So again, I'm going to mark the San Diego location because that is the one that gets the most precipitation out of these two. And then I have my temperature range. San Diego's is 9.1 and El Centro is 20.3. So it gets much warmer and much cooler, throughout the year. Whereas San Diego, the temperature doesn't change very much throughout the year. 9 degrees up and down. Now let's look at my last 2 cities. So far I'm seeing that the city that is closer inland, or closer to the ocean, I should say, gets more precipitation and has a lower temperature range. Let's see if that continues to hold true. So I'm looking at San Francisco versus Modesto, same latitudes, distance to ocean, 0 versus 129 kilometers. Annual precipitation. So let's see, the San Francisco was 56.5, Modesto 33.3. So again, San Francisco gets quite a bit more rain. And look at San Francisco's temperature range, 6.4. That means very mild weather throughout the year compared to Modesto, which is 17.5. Okay. So now let's take a look at, kind of what this means here and talk about that. So I'm going to have us go to the next page here. So I had you glue this in yesterday, and if for some reason you weren't here, just take screenshots of this so you can fill it in when you come back. But like I said, all of you should have this glued in from yesterday. So our first question is, how does the distance from the ocean seem to affect the temperature range of the cities? So distance from ocean, how does that affect the temperature range of the cities? Well, if I'm close to the ocean, I'm looking at my last column here. So the 0, 0, 0s, they all are the ones that have the lower temperature range. That's the ones that I marked here with the black star. And if they're farther from the ocean, they have a higher temperature range, right? So that's essentially what I want to write down for number 1. I want to put down both of those. So I'll leave this up here for a second for you to copy down. So if they're closer to the ocean, their temperature range is lower. Doesn't mean they have cold temps. It just means that they stay more mild in terms of temperature. They don't get too hot and they don't get too cold. They stay similar in temperature more throughout the entire year. And if they're farther from the ocean, that usually means, or according to this, these cities have higher temperature ranges, usually meaning they get quite a bit more warmer and maybe more cooler during the winter months. All right. So number 2 says, what conclusion can we draw about the relationship between distance from the ocean and temperature range? So a similar style question. We're just kind of comparing, the 2 here to come up with a relationship, but you're going to see the same idea come up in this answer here. So cities that are closer to the ocean have lower temperature ranges. And again, I put in parentheses here what that means. It means that their weather is more mild. Again, they don't get too warm. They don't get too cool. They sort of stay similar in temperature throughout the year. That's what a low temperature range means. All right. And then I didn't write this in there, but the opposite is obviously also true. So if cities that are farther from the ocean have higher temperature ranges, and just means that they have more, cooler winters and warmer summers, essentially is what that would come out to. Okay, their temperatures get a little bit lower in the winter and a little bit higher in the summer. All right, so let's take a look at 3. So the other thing, again, that we looked at was precipitation, rainfall for most of these locations, but precipitation also includes snow. It just is measured a little bit differently. About a foot of snow equals a foot of or an inch of precipitation. So it doesn't mean that it's all, snowfall. But what did you notice about precipitation for cities close to the ocean compared to those with similar latitude and elevation farther inland? All right, so let's take a quick look back at our page here. So I'm noticing that the cities that are closer to the coast, right, the ones with the black stars here are the ones that have the higher precipitation. All right, the ones that are further inland have, much lower precipitation, quite a bit. We're not talking like a centimeter or 2 difference. We're talking like, some of them are half or less than half difference in temperature here. So for number 3, we're going to kind of word it similar to number 1, just change the ending part here. So if cities are closer to the ocean, usually they will have more precipitation. And cities that are farther inland, I just put farther inland instead of farther from the ocean, same meaning, have less precipitation. So something about the ocean must be causing more precipitation, or being close to the ocean. That's kind of the conclusion that we want to get from this here, and I'll discuss why that is at the very last question. All righty. So number 4, similar to number 2, what conclusion can we make? Again, kind of comparing these two, similar wording here, but let's go with this. So cities that are closer to the ocean have more precipitation than cities inland. That's the conclusion that we want to make with this. Cities that are closer to the ocean have more precipitation than cities that are farther inland. All right. So as we finish this up, we want to look at our last question here. It says, what do you think causes the relationships that you identified in items 2 and 4? So what causes the oceans to have, the effect of having milder, lower temperature ranges on those cities? And what about the ocean affects them to have more precipitation than cities that are inland? So the cause of this is 2 different things. So we have to come up with 2 different causes here for number 5. All right. So I'll start with the first one as far as which one? Okay, yeah, so I did the temperature one here first. So this first one here will tell me why the temperature range stays pretty similar all year long. So the ocean is a very large body of water. And if you guys remember from our experiments that water takes a lot longer to heat up and cool down. And so water tends to stay more of a consistent temperature throughout the year. Even if it's not quite getting as much sunlight, pointed away from the sun, tilted away from the sun during winter months, water generally stays, ocean water at least generally, doesn't get, crazy, crazy cool and crazy, crazy warm. So because the ocean temperature stays, in a lower range, that affects your air temperature. So remember that the water temperature conducts its heat or its molecules or its kinetic energy to the air particles that are above it. And so whatever the temperature is of the water, if it's really warm, that'll make the air warm. If it's cool, that'll make the air cooler. That's the effect that temperature has on air. The ocean temperature has on air. So if the ocean stays relatively, mild in terms of its temperature ranges, then that affects the air temperatures around coastal cities. Now, the reason that when we move inland, we don't see that anymore is because it only has an effect around those coasts, at some point, then the land temperature sort of takes back over. All right. So we only see that right around maybe like the first, 10 or so kilometers, or maybe 50 kilometers or so around coastlines. All right, and then the very last one here is the relationship between precipitation and the ocean. So what does the ocean have to do with precipitation? Well, remember that where does precipitation come from? If we work backwards in the water cycle, it comes from condensation that comes from cloud formation, and cloud formation comes from evaporation. Evaporation comes from bodies of water. Large oceans evaporate lots of water. Lots of water vapor will condense into lots of clouds. Lots of clouds will eventually form precipitation. Okay. So again, the oceans are a huge source of water that is evaporated, goes up into the air where it cools, condenses into cloud droplets, which are very small. But eventually those cloud droplets will come together because there's more and more water vapor getting evaporated. And if they get big enough, they'll fall in the form of precipitation. Now, the reason that this only affects coastal cities is because the clouds will move inland. Okay, so they'll start at the coastal city, drop lots of precipitation there, but eventually they sort of fizzle out because they lose their source of water vapor. As the clouds move farther inland, eventually all the water is just going to, fall as precipitation. Not all, most of the water will fall as precipitation, and they'll sort of lose their source because they're no longer above a large body of water to get the more water vapor from. So cities that are inland are much drier than cities that are on the coast. All right. So this is all I have for you today. I'll check this on Tuesday. And if you don't have any questions or need to finish this up, you're free to go. Have a great day, guys.